Guten Tag. Thank you for coming to my presentation. Today I'll be talking about Koura's low GWP refrigerants, solutions ranging from comfort cooling to ultra-low temperature refrigeration. So our Orbia Flora and Energy Materials business and Koura brand are unique because we are the world's largest fluorospars producer, which allows us to secure a mine-to-market approach through our vertically integrated structure. We are constantly optimizing and investing in our current portfolio, including our low carbon footprint refrigerants, as well as our sustainable energy materials, sustainable energy fluorinated materials. Today I'll provide an overview of Koura refrigerants. First off, I'll talk about our lower GWP commercially available retrofit solutions for existing systems. The first product is CLIA 456A, which is a low GWP 134A replacement. It's non-flammable, the same safety classification as 134A for easy adoption, and it provides a 50% lower GWP, which allows reduced carbon-based imposed taxes. Initially, this product has been launched to support the auto aftermarket, which went through an earlier transition in terms of lower GWP products. And so this product has been qualified by over 20 plus brands of AC charging equipment in Europe, and it has been successfully servicing 134A vehicles for the last 2 years. While it was initially developed for auto aftermarket, it could also be used for stationary applications that use 134A, such as cold chain, chillers, and heating sectors. So looking at some of the thermodynamic properties of 456A, it has been designed to closely match 134A with the same safety classification. And one of those most important factors when you consider an alternative solution is the performance of the refrigerant and how it compares to the incumbent refrigerant. In the case of 456A, the relative COP or efficiency are essentially equivalent with a slight improvement in volumetric capacity. The second product is CLIA Edge 444A, which is a direct replacement to 1234YF. It maintains the same mildly flammable safety classification and offers a faster pull-down rate. This product is type approved and has been approved by at least 3 brands of AC charging equipment in Europe, while others are in progress. And while this product, again, has been developed to provide a solution for the auto aftermarket, it is also available for original equipment car manufacturers that are seeking alternative solutions. And again, similar to 456A, applications that use the low to medium pressure refrigerant can utilize this refrigerant, such as cold chain, chillers, and heating sectors. Looking at the properties, 444A is a 3-component blend, and the GWP is 88, so it meets the MAC directive, as well as some of the long-term GWP-based limits as set in the F-gas or the AMAC. Looking at the performance, the COP or the efficiency is 5% better compared to 1234YF, and then it also offers a 12% boost in volumetric capacity. Koura worked closely with major recovery, recycling, and recharging our surface trolley manufacturers to help the market easily adopt 456A and 444A. And we also have technical literature available to help with the refrigerant conversion through our service guides and technical data sheets. Switching gears, the last retrofit solution is CLIA 473A, which is a solution for ultra-low temperature refrigeration. This product, again, is non-flammable to match the incumbent R23 and 508 safety classification. And while this particular sector is traditionally or typically exempt for many of the regulations because of its extreme condition, Koura developed this product to ensure a reliable long-term supply and also provide a solution that can reduce your carbon footprint by 85%. This product's been recognized as Refrigeration Innovation of the Year during the 2022 Rack Cooling Industry Awards. And the world's leading ultra-low temperature transportation companies such as Merck's has already adopted this product. Typical applications for this product is low temperature refrigeration that needs a cooling temperature below minus 50 degrees Celsius, such as high-value cold chain, pharmaceutical, test chambers, and medical supplies. Looking at the properties of the refrigerant, especially the performance, if you look at the relative COP, essentially they're comparable, R23 and 473A. You do get a decent boost in volumetric capacity by 20% by switching to 473A. It also has a relatively low collide of 2.5 Kelvin, making it easy to adopt. One thing worth noticing is 473A does tend to have a higher compressor discharge temperature as shown in the higher isentropic index value. And so there's ways to mitigate that by utilizing the 20% higher volumetric capacity and adjusting your upper stage load and to mitigate the higher discharge temperatures. Next, we carried out a case study in a R23-based environmental chamber. And so in this chart, we're showing R23 versus 473A and the cool down rate starting from 130 down to minus 40, and how long does that take? And so when you compare the two refrigerants, essentially they're very similar. Again, this is a drop-in study, so no changes were made to the system. And so these results were satisfactory to the manufacturer. And the same amount of refrigerant charge was used based on the user guide provided by the equipment manufacturer. We also didn't make any changes to the existing original POE 32 oil, and we did not see any issues with 473A for prolonged operations. Switching gears, I will next talk about our below 150 GWP solutions for new systems. So first product is Clear Edge 485A. We all know that R744 or CO2 is under heightened interest because of its low GWP, non-flammable characteristic, and natural presence in the environment. But because of its lower efficiency in warmer climate, that kind of hinders the wide adoption of the product. To that end, we developed 485A, which demonstrated an efficiency improvement versus CO2 up to 25%, which makes it a viable option even in warmer climates. On the right-hand figure, I'm showing a map of Western Europe and mapping how the different summer climates impact the efficiency of 744 and 485A and how it compares to fluorinated solutions. So the northern part of Western Europe, shown in green, both 744 or 485A could be effectively used compared to incumbent refrigerants. However, if you look at the area shown in yellow, the southern part of Western Europe, because they have hotter summers, the efficiency of 744 starts to drop off, while 485A maintains superior efficiency, making it a good solution for the entire Western Europe. 485A is a blend, and all of the components are considered non-PFAS, even under the most restrictive ECHA definition. As all of you know, there's many definitions of PFAS. So in this case, it is considered non-PFAS for 485A. It's also a non-flammable for handling solution. So comparing it to mildly flammable A2L refrigerants with similar GWP, that could be an added benefit. Some benefits of utilizing 485A or some applications that can use 485A would be cold chain, heating, and both stationary and mobile air conditioning. So looking at the composition, you will see that R744 is the major component with the other two non-PFAS components completing the blend composition. The GWP is 142, so it's below the 150 value. The properties of 485A is very similar to 744, meaning that you don't have to invent or develop new components and systems, particularly for this refrigerant. You can continue to use your CO2 systems and components. I would like to highlight two properties. First one being the pressure. We know that 744 has very high pressure. 485A does reduce your pressure by about 20%. And another key parameter is the critical temperature difference. So 485A has a 10 degrees C higher critical temperature, which allows the improved efficacy in warmer climates. So as an example, we can map out 744 and 485A in a pressure enthalpy chart on the right-hand side. And this is for a split pressure cycle with the ambient air temperature of 32 degrees C. And in the case of 744, shown in red, you'll see that the heat rejection occurs above the two-phase dome, indicating it's a transcritical operation, which hurts the efficiency of CO2. On the other hand, for 485A, shown in blue, you see that the upper heat rejection sits below the two-phase dome, so it's a subcritical operation, and that's where you see the performance improvement of 485A over CO2. Next, we carried out an experimental evaluation. So 485A was dropped and tested in a 744 monoblock heat pump water heater. And for this test, we used the same refrigerant charge as indicated in the user manual for the equipment manufacturer. We did carry out a soft optimization to independently control the water flow, the compressor speed, evaporator airflow, and the gas cooler pressure. So we assessed the performance of the refrigerants by varying the gas cooler pressure and finding the maximum efficiency as well as the optimum operating condition. If you look at the left-hand figure, which is the heating COP, you'll see that 485A had a 9% improvement in maximum COP versus CO2, and that was at a 20% lower operating pressure. And so while we expected 485A to have improvement in cooling, we also saw the performance benefit in heating applications. Next, we looked at the heating capacity and water temperature, and the rated condition for this equipment was 35 degrees C water temperature at 4 kilowatt capacity, and both of these refrigerants were able to achieve that. Moving on to the last refrigerant, which is Clea Edge 492A. This was developed as an alternative to propane. As we all know, propane, similar to CO2, is also under heightened interest. However, because of its higher flammability, being an A3 refrigerant, there are restrictions that come with that, such as the charge limitations. You might have to install your unit outdoors. Maybe you have to utilize a secondary loop and changing your structure, and there's a challenge in servicing the equipment. And so 492A was developed to closely match the properties of 290 while having a lower safety classification. So in the case of 492A, it has a 5-time higher LFL compared to propane, allowing higher refrigerant charge. It has comparable performance versus 290, And again, because of the similar properties, you're able to utilize the same system components. Because 492A has a decent glide between 8 to 10 Kelvin, there's further opportunities to exploit the glide for air-to-water or water-to-water systems. In that case, you can expect a 10 to 22% COP gain, depending on how you size your heat exchanger, and utilizing your shift in water temperature along with the refrigerant glide. Potential applications are where propane is being considered, electric vehicles having heat pumps, that's a potential opportunity, as well as chillers and heating segments. To kind of map out how the flammability differs between 492A and 290, I'm showing 4 different flammability parameters that are commonly used in assessing flammable fluids. Starting with the left-hand side, I'm showing minimum ignition energy versus lower flammability limit. So if you are on the lower left corner where your hydrocarbons, class 3 refrigerants, 152A is also there, it means you only need a little bit of refrigerant to ignite that fuel. If you have a low minimum ignition energy, it means you only need a small ignition source to ignite the refrigerant. So in the case of class 3 and 152A, the static electricity from a human body is enough to actually ignite those fluids. In the case of 2L refrigerants, you can see that they are clustered on the upper right corner, noting that this is the log scale on the y-axis, and you'll see that 492A is much closer to the 2L refrigerants. Moving on to the right-hand figure, which is heat of combustion versus burning velocity. So these two parameters are actually used to classify refrigerants in ASHRAE 34 and ISO 817. And as you go up in both values, that means your ignition event is more impactful or stronger. And you'll see the class 3 refrigerants in the upper right corner, the 2L refrigerants and 492A in the lower left corner, and then 152A, a class 2 refrigerant with higher burning velocity somewhere in the middle. So in conclusion, Koura offers a broad range of refrigerants to help navigate the refrigerant transition, including our legacy CLIA HFC products, our lower GWP retrofit solutions, and our below 150 GWP CLIA Edge products, where we're working closely and engaging our customers to develop solutions that meet their needs. If you'd like to discuss more or learn more about our refrigerants, please visit us at booth 429 in Hall 9. Thank you for your attention.